All right, peeps, as you heard, we're talking about two of our favorite things today, sports cars and additive manufacturing.
Let's go, baby.
But before we get into today's episode, we're going to talk about one of our favorite sponsors. That's going to be Mauser Electronics. Now, Dan, tell the great people, why do we love Mauser Electronics so much?
We love working with Mauser, not because they're an awesome electronics supplier, which they are, but because on top of that, because of their awesome connections to cool startups, cool academics, cool companies, making innovative things, they've got a good finger on the pulse of what the innovative things are, and they write awesome articles about them as well. So they're not only a place for you to get your electronics, they're a place for you to get your knowledge as well. And that's what we're all about on this podcast, getting knowledge.
Absolutely. And they offer these like little tidbits, little sprinkles of insight about what could be coming down the road for a specific industry. So let's take a look at this article that we're going to be linking in our show notes from Mauser. They talk about how additive manufacturing has been making waves. And they talk about how it could potentially be leveraged in the automotive world. You know, it starts off kind of easy, like, yeah, you could have like certain parts that could be customized. You could have a car that completely drastically changes how you interact with your car because we're spending, as Americans, an average of 100 minutes every single day in it. So imagine if the totality of that time can now be spent in a fully custom environment that fits, that has everything fitted to your desires to do work the way that you need to do work, or to relax the way you want to relax. And they draw up this potential of the future car.
Well, and I think that they start at like one point in time where they're like, all right, we can use 3D printing to help personalize aspects of everyone's vehicle. And we've covered Machina Labs on this podcast before.
I was going to bring him up. Great timing.
Ed Mayer from Machina Labs, one of our friends, CEO of Machina. We interviewed him on the podcast. He talks a lot about like using additive manufacturing and using roboforming, which is their technology, but using next generation manufacturing, you can make a customizable car.
And he's been hinting it. He's been hinting at it for a while.
Then they say the next step for 3D printing is, instead of doing low volume personalized car production, they can switch into high volume production, printing cars on demand, reshaping the way that we produce cars. Also, interestingly, was it today the Bugatti Tourbillon came out?
Yep.
And they're using a 3D printed chassis from Divergent.
100% completely additively manufactured. And it's, again, this article I think came out 2 or 3 years ago by Mauser, but it predicted what this landscape would look like quite well, actually. So, like I said, we're going to be linking in the show notes. As always, if you're interested, definitely go and check it out. And with that said, let's move into today's article.
Well, and it's a perfect complement to today's article. It's the cookie to the tea for today's article, because this article from today, we're talking about streamlining manufacturing processes in the automotive manufacturing realm using 3D printing. Again, just another testament. Mauser teed this up perfectly for us, but we're talking about Audi.
We are. And since we're talking about our European friends, I think you meant biscuit with your T, not
That's
cookie.
true. Sorry.
Do better. Come on now.
Man.
Come on. But yes, we're talking about Audi, and specifically about Audi manufacturing. They have a manufacturing plant in Germany that for the longest time had been focused on the Audi R8, which is their, super sport offering. It went head to head with the greats like the Porsche 911s, like the Ferraris, depending on, which end you were at, the 458s, let's say. So incredible car. I loved it. I remember Tony Stark driving one and oh my God, Iron Man. There we go. Yeah. The first one. I guess in every one of them, actually. But anyways, so this is like a high-end plant that's producing very high-end vehicles that are typically very, very customized by the people that are ordering them. Now, as times have changed, as electronic cars have become more common, they're also producing the Audi e-tron GT.
Which is another beautiful car.
Gorgeous. Absolutely gorgeous.
And I think the most powerful Audi ever produced.
I think the new generation is. You're right.
Yeah.
And what's interesting is that once this car was proposed and manufacturing had to start, the folks that worked at this plant were like, okay, well, we need approximately 200 new jigs, tools, and fixtures so that we can do our jobs properly. Now, just a little bit of context here for those not super familiar with manufacturing. I'm honestly not an expert, but I know a little bit. So fill in the gap here, because you're the automotive guy in this podcast. But essentially, as you have people working on the assembly line, parts are coming down, you have a limited amount of time. You want to fit the pieces on that you're supposed to put on with as great of an accuracy as you can. Ideally, you want it to be comfortable for you. There might be spots that are like really tough to get to. So some of these tools, like custom tools that you get and the fixtures and jigs, help you do that. But probably most importantly to the end consumer, it allows them to do something in a repeated manner with a very high quality, like applying the logo or like lining up pieces of the car. Is that about right?
Well, yeah, and that's what I was going to say. Is the most important part from a quality perspective is being able to do it, put the part in the right spot, in the right manner, repeatedly, right? It doesn't matter if you can do it one time where the part's in the right spot, or if you can do it, but it takes a lot of time.
Yeah.
Or if you can do it, but you can't do it again on the next car. You need to be able to do it quickly. You need to be able to locate parts correctly without damaging them. And you need to be able to do it repeatedly on an assembly line again and again and again, because you're making multiple cars per day. Like you said, tools, there's different categories. There's tools called jigs that like hold the part in place, fixtures that are support structures to help locate parts. These tools called jigs and fixtures on an assembly line cost a lot of money and take a lot of time to develop on the first part and then later to produce. And so when you're talking about Audi, when they're changing their line over to be able to produce the e-tron GT and they need almost 200 new tools, that's
a tall order.
That's a tall order from a dollars perspective and a time perspective, because you could spend thousands and thousands of dollars on every single jig. And you can also spend weeks and weeks and weeks waiting for those jigs and fixtures to show up. So Audi, on this really efficient assembly line that's already been used for a lot of different car production, they're trying to do a fast-paced switch over to e-tron GT so they can launch it quickly. When you look at this challenge of saying we need 200 new tools quickly, they need to be dimensionally accurate, because even a part being a millimeter off, the human eye can tell when there's a panel gap difference. So you need really, really accurate jigs. You need them really, really quickly, and you need them in a way that's not going to break the bank. It sounds like an impossible challenge until you bring in 3D printing.
Absolutely. And that's a great point to take a moment and talk about why there's so much like time inefficiency and cost inefficiency associated with getting these jigs if you were to go the traditional route, right? So the first part is to create the jigs, someone has to design it. Like someone has to sit down, CAD it up, usually a mechanical designer. Now that could be someone in-house, or it could be someone from a third-party supplier.
Mm-hmm.
If they're from a third-party supplier, you're just paying them more money. If there's someone in-house, that means you're taking them away from other tasks that they could be working on. So that's one set of costs right there. The other part is the actual manufacturing process. Now, if you were to go down the traditional route, the reason that there's usually weeks of lead time is because for, let's say, a injection molded part, they would have to create the mold, verify it, and then start the manufacturing for it. And then, I think the person that they were talking to who was in charge of this process at Audi said it could be weeks, but probably months to get a part.
Especially when you're talking about, I think even less so than the injection molded parts, is when you're talking about these custom jigs that these manufacturers are only going to make one of, and they have to be sub-millimeter level of accuracy.
It's the machine.
What you're going to end up is someone machining parts.
Yeah.
Probably manually, or at least using a CNC machine, but they're not only taking time to design the parts and then design the assembly of the parts, they're manually machining every single aspect of this jig, assembling it, and then shipping it to you. And it could, anywhere between weeks and months, you stack up all those steps, you end up with a part that costs a lot of money, took a lot of time, and it's only a tool that you're using to help assemble your product. So it's not something that's going to the end customer. Audi can pass the cost right on to the customer, right? It's a tool that they need in their manufacturing plant to even turn it on, to even get it to work. And like you're saying, the traditional manufacturing method for these jigs, for these fixtures, commonly involve things like machining, like prototype, like almost prototype scale manufacturing, where you're only making one or two of these. It involves a lot of feedback from the engineers designing the fixtures and a lot of manual technicians physically building these parts by hand.
And with that in mind, you'd kind of understand why traditionally, if it were up to someone to decide if a jig or a tool or a fixture is getting made, they would assess it by, is this absolutely needed or not?
Yeah.
Right? Like if something was just going to make the process marginally better, it's probably like, maybe not worth it. Like if it doesn't have a tremendous amount of value add. But now let's start talking about additive manufacturing, right? And I guess before we get to the actual manufacturing process, it's worth noting that the great folks at Audi wanted to talk about this software they were using that was made by a company called Trinkle. They created a software called Fixture Mate, as I'm sure you can tell by the name. Its job is to create fixtures.
It helps you make fixtures, mate.
Yeah, mate. We jumped from Europe to Australia, but
I thought the software is really, really cool. And we can kind of talk about how it fits into the big picture of 3D printing. But essentially, when we're talking about the normal fixture design process, it requires 2 steps. It requires a fixture design engineer or a manufacturing engineer to help create the design for the fixture, and then somebody to go manufacture it.
Correct.
And, you can't just say like, oh, I'm going to buy a bunch of 3D printers and I'm going to solve my fixture design problem without something to help with the fixture design, the first portion of that process. So this Fixture Mate software, as I understand it, you kind of define the constraints, right? You understand where the parts, you import the geometry of the part, you help set them at the right angle, the right position, and then the Fixture Mate software helps add supports and mounting features to help improve the dimensional quality of assembling that part, on the rest of the assembly line. And essentially, it not only takes into account where supports might be needed, where mounting fixtures might be needed, it also has a library of a bunch of tools in there like clamps, pins, etc., to help make the design process faster. Essentially, the way I think of it is it's like big boy Legos. It's like if you're fixture designing, that's
a good way of explaining
gives you a kit of a bunch of bricks, gives you some basic instructions to say like, oh, if you want to build this shape, you can just kind of mash these blocks together and bang, you've got a fixture. It kind of gives someone, instead of designing from scratch, they get the geometry built in for different clamps, different supports, different mounting features, etc., that you might commonly need on a fixture.
The way I was thinking about it is, as long as you understand what this fixture needs to do and what its constraints are supposed to be, you don't exactly need to know CAD. Like, that is what it's taking care of for you. So anyone who has knowledge of what needs to be made can kind of come in, play around with the tool, and get going. And again, the person that runs the shop made a point of explicitly saying, we went from having mechanical designers do this job to trainees that were just like, this is how the software works. Go nuts. Now it's your job to make some fixtures.
Bang.
So I'm sure that's worth quite a lot to the team at Audi.
Yeah.
But now let's switch over and talk about the second half of the secret sauce, which is the actual additive manufacturing that's taking place.
The 3D printers.
The 3D printers.
Ultimaker S5.
S5, super reliable. It's been around for quite some time now. It's a powerhouse of a unit, and it supports quite a few material types, which the team at Audi really appreciates, because as they're assembling these vehicles, they were talking about how they use like tough PLA for rigid parts that they're going to be beating around, but they also use ESD safe PLA, I think, or maybe it was a different plastic, to just make sure if they're using with electrical components that there's no static discharge that destroys a part.
Yeah, and I think that covers it. I was looking at my notes here. Tough PLA, strong and easy to print. TPU 95A, which is soft and protective for delicate parts, and then ESD safe PLA, so you can touch electronic parts without destroying them.
Yeah, I think they also use PETG and ABS. I don't think they said explicitly for what, but it was interesting to hear them talk about how I guess one of the benefits that they saw within the Ultimaker ecosystem was that there's a lot of support, not just for the Ultimaker materials that they sell, but also like hundreds of material profiles that are sold by third parties. So if they wanted something that Ultimaker didn't sell, they could also use it without much hassle.
Yeah.
And that was cool. In addition to that, let's see. What was it that I want to talk about? Let me look at my notes.
Well, I wanted to brag on the Ultimaker S5 accuracy, right? Because we talked about these parts, these fixtures rather, needing to be very, very accurate, so that you could get the part in the right place. And I kind of mentioned it earlier, but it's surprising how small of a difference or a gap or an error or a variation can be in automotive assembly, and the human eye can pick it up like that. I remember when I worked at Tesla, we had some challenges with panel gaps on the Model Y when we were first launching it. And it'd be like the tailgate on one side of the tailgate, there would be a 6.5 millimeter gap. And then on the right side of the tailgate, there would be a 7 millimeter gap. And that's only 0.5 millimeter difference between the two. But you could look at that with the naked eye and be like, man, this thing's closer to the left than it is to the right. Like it feels off. And when you've got a company, a luxury car company like Audi making an expensive car like the e-tron GT, they can't afford to mess up on panel gaps. They can't afford to mess up in assembly. They can't afford to damage the parts. So you want to make sure that these fixtures are very, very accurate. Fortunately, the Ultimaker S5, and this is true kind of inherently of 3D printing, but I think Ultimaker more so than many of the other like hobbyist desktop 3D printers, really, really focuses on getting a professional level of accuracy. And when I say a professional level of accuracy, I think they have accuracy to the 7 microns, I think, which is 7,000th of a millimeter. Mm-hmm. Or just about 3/10,000ths of an inch for you Imperial folks. So small. I guarantee you your eye can't tell the difference. That's the level of accuracy that they have with these parts, which is perfect for making fixtures, which are supposed to be your source of truth for locating parts. So I wanted to mention specifically 3D printing actually probably provides a competitive advantage over machining on some of these parts and some of these materials. Based off of just how accurate 3D printing can be.
I'm happy you brought that up because it made me remember what I wanted to say that I was blanking on earlier. And that is, again, let's go back and talk about what these cars are. There are ultra luxury cars for people that are paying a lot of money to have a custom piece made, and they're expecting top quality stuff coming out, right? So one thing that is becoming more and more common in cars is the heads-up display, which is a laser projected, what is it? Indicator, I guess. And to set that up and make sure it's working properly, you want to align like the laser or the mirrors or whatever. And to make sure that that's actually aligning in the way it should, the folks at Audi are using jigs that were created by this Ultimaker S5 printer. And that is what's giving them the reassurance that like, this is good to go. Now imagine if that wasn't there and the human was trying to like move this thing like back and forth 1 millimeter, 2 millimeter until they get it right. They would waste a lot of time, probably hours, for not just that one process, but for everything together. And now they have a jig that they could probably just slide stuff into. And again, based on what you were saying, 7 micron accuracy, that all is good.
Yeah, and exactly what you're saying about the premiumness of the product. It's awesome that we're able to use a type of technology that a lot of people have tried to pigeonhole into prototyping only, which is 3D printing, actually in a production setting. And it provides a lot of competitive advantages. We've already talked about, I think the main one here was the time to iterate. They were quick to be able to set up. I think they first said they needed to do 200 tools and fixtures. They ended up doing upwards of 800 because people keep asking, right? Saying, well, we need to change this. We can tweak this. We can do this faster. It allows them to make the design process faster, iterate quickly in case they need to make any quick adjustments because the parts don't cost a lot and they're really, really quick to produce. They can do them in less than a day. And I also want to mention from a supply chain perspective, you can avoid the delays of like, oh, we put this on a truck, maybe it got stuck in customs or someone didn't fill out the correct paperwork. Like that's just every single layer of complexity you add to a supply chain. And speaking from experience here, it's an opportunity for things to go wrong.
Right.
And by doing this in-house, they've vertically integrated their own fixture development and production to where, if they want to change the line over from the 2023 e-tron GT to the 2024 e-tron GT, they can do this in-house. They can change these fixtures and not spend a lot of money, not spend a lot of time, and not take on a lot of risk. And the major unlock for them there was bringing their means of manufacturing on site. And in this case, they didn't build a giant machine shop. They bought a couple 3D printers.
Absolutely. And the key benefit of all this kind of boils down to this one line during the interview that's linked in the article, which I think people should watch. And the person that runs the 3D printing shop was like, yeah, what we've reached at this point is that you have a factory worker come up and is like, hey, this tool would really like help me out with my work. And like tomorrow morning they have it. There's no more like, yeah, let's take it into consideration. Now let's have the designer look at it. Well, the designer's finally done making it, so let's send it off to the manufacturer. That manufacturer has not made it. They're shipping it. It's here. Oh, it's been 3 months, and like the value add that you were looking for is probably just diminished by now.
Well, and I'm even thinking about the way they've empowered their workers, right, to raise their hand when they say, "Oh, this portion of assembly is challenging, or this portion of assembly isn't ergonomically safe for me to do." You would hate to be put in a position where, for a time constraint or for a cost constraint, you have to tell a worker who's like mustered up the gumption to raise their hand and say, "I need help with this." Tell them, "No, sorry, we can't help you."
Right.
Like, you have to keep doing this sucky job and hurting your fingers when you're trying to assemble this thing, or you have to keep doing the sucky job and keep placing the part in the wrong place and then have to replace it again to try and get it correctly. In this case, where you've lowered the barrier here, right? You've lowered the barrier to entry for creating new fixtures, for creating new jigs. You've got the opportunity to create custom fixtures to help workers make their jobs easier, ensure high quality standards, ensure safety, boost productivity. And I feel like personally as a worker, like if I had raised my hand and said like, "Oh, I need a tool," and you can help in the design of this process using the FixtureMate software, it makes me take a lot more pride in my work and make sure that the cars that are assembled are beautiful. They work perfectly. They don't require any touch-ups and end of line before they get sent out the door. Like this is, and especially having worked with some folks who had like previously worked at German automakers like VW and Audi, like they take quality a really, really high standard. And this is something that falls in line with this quality culture that they have, which is, let's give all the workers the means they need to do their job perfectly. And
right.
I like the idea of leveraging 3D printing to help enable that.
Peak German engineering.
Yeah.
Yeah. So with that said, let's try to wrap up what we just talked about, right? You got the Audi plant that's creating Audi R8s and the Audi e-tron GT, like their most luxurious vehicles. And in order for the factory workers to actually do their job right, they need a lot of these custom tools, jigs, and fixtures, which traditionally would require a mechanical designer to create it, send it off to some manufacturer, take a couple weeks or even months for them to get the parts back. This is expensive. It takes a lot of time, but additive manufacturing and a bit of generative design has shaken up that world, because now the Audi team is using this software called FixtureMate, where a trainee, someone that doesn't even know how to do computer-aided design, can bring in the part they want, generate a fixture, and then use an Ultimaker S5 3D printer, which you can get like off of anywhere at this point, and use a whole multitude of materials, from very tough PLA to ESD safe, which is going to make sure that you don't have static electricity damaging your parts, to create whatever you want. And it's been so effective that workers have been coming up and requesting more parts, to the point that they went from the anticipated 200 jigs to about 800 now. And that is why they're able to produce better cars than anyone else out there.
I love it.
The Germans do it different. Anything else? Do we have shout outs to give? Do we have any love to share? Any food reviews?
I have 3 thank yous to give.
3 thank yous. Thank away.
The first of which to Ireland. I think we were a top 50 podcast in Ireland. The official language in Ireland is English, so I'm going to say thank you.
Are we going to eat haggis this weekend?
I don't know about that, but I was going to say maybe by next episode I'll learn how to say thank you in Gaelic.
Good man.
Also, a huge thank you to our friends in New Zealand. We were a top 200 podcast in New Zealand. The official language in New Zealand is English, so I'm going to say thank you.
And I eat lamb every day, so I got you guys there.
But thank you to our Kiwi friends in New Zealand. Maybe I'll learn to say thank you in Maori, which is one of the local languages. Yeah. Also, top 100 podcast in Nigeria, where the official language is also English. So I'm going to say thank you.
Wait, no way? Really?
Yeah, I looked it up just to be sure.
Well, wow. Okay.
There are also other major languages called Hausa, Yoruba, Igbo, Fulfulde. We'll find a way to say thank you, and at least one of those, maybe.
Yeah, we'll round it up next time.
By the next time we record it.
Keep us accountable.
Thank you to our friends around the world. Pitbull calls himself Mr. Worldwide. I think we're more worldwide than Pitbull is.
Those are fighting words, man. I don't want him coming after us.
We're Misters Worldwide.
I like the way you think. There's 2 of us. There's only one Mr. Worldwide. All right, folks. Thank you for listening. As always, we'll catch you in the next one.
Peace.